Hello everyone. So today we are going to see a new dynamic programming problem, which is the house robber problem from Leetcode. So let's jump to the problem statement and try to understand what they are saying. So they are saying you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. So given an integer array nums representing the amount of money in each house, return the maximum amount of money that you can rob without alerting the police. So basically the restriction is that we cannot rob two adjacent houses or the police will be alerted. So let's go to the example. So here they have given us four houses and the money they are containing is 1, 2, 3, and 1. The expected output is 4 and the explanation says that we can rob house number 1. We will get money 1 and then we can rob house number 3. Since 1 and 3 are not adjacent, we can pick both these houses. So it will give us total amount of money 3. Then 3 plus 1, our overall total amount of money that we can rob is 4. Another example, it's 2, 7, 9, 3, and 1, and the expected output is 12. Then the explanation says we can rob house number 1, house number 3, and house number 5. So 1, 3, and 5. None of these houses are adjacent to each other, so it's perfectly allowed, and the police will not be alerted. So the total amount of money that we can get is 2 plus 9 plus 5, which is, oh sorry, 2 plus 9 plus 1, which is 12. Cool. So let's try to break down this problem using an example, and we will understand how the logic is working. Okay, so I'm using example number 2, which is given in the problem, to help you understand how we should approach this problem. So overall numbers array that is given to us is 2, 7, 9, 3, and 1. But let's start with the very beginning. Let's try to understand how this will how we should approach this. If let's say we had only one house, so let us assume the array was just this. There was only one house, which is 2. So if I ask you what should be the output for this case, if there is only one house and I ask you how much money can you rob, you will simply say there is one house, there is nothing restricting us from robbing it. So the result here will be just simply 2. There is only one house which can give us 2 amount of money. Then let's say we increase it by one step. Now we have two houses, 2 and 7. Now I ask you what should be the output. So now, as per the given condition, this condition basically forbids us from choosing any two successive or adjacent houses. So if we have two houses with values 2 and 7, if I pick the house with value 2, then I cannot pick the house with value 7, and vice versa. If I pick the house with value 7, then I cannot pick the house with value 2 because these two are adjacent. So the only choice is I can either put 2 or I can pick 7. So if I ask you which one should I pick, you will simply say, okay, if I pick the house with value 7, I can get more money. So here my output will be 7. Now let's take it one step further. Now let's say we have three houses, 2, 7, and 9. Now it becomes interesting. So again, keeping that condition in mind, if let's say I pick house number 9, then can I pick house with value 7? No, because 7 and 9 are adjacent. So if I have picked house with value 9, it's like ensured that I cannot pick the house with value 7, but I can pick the house with value 2 because 2 and 9, they are not adjacent. So it's perfectly safe to pick both of these. So I can either pick 2 and 9. This is my one choice. Other choice could have been I could have picked the house with value 7, but then I can neither pick 2 nor I can pick 9 because both of these are adjacent to 7. So I have two choices here. Either I can take 2 plus 9 or I can take 7. So if I ask you which is better for us, you will simply say 11 is greater than 7. And since we want to maximize our benefit, we will simply pick 2 and 9. So we will say that in this case, my overall output should be 11. Now let's say we take in one more step further. Now things will start becoming clear. So let's say I have 2, 7, 9, and 3. Now what should be the output? Again, let's try to break it down the way we broke down when we had three houses. We started from the very last element. So let's say here also, now I am at value 3. I have two choices. Either I can rob the current house or I can not rob the current house. So let's go by the choice where I am first of all robbing the current house. So what will happen? I will get the value 3. There will be something more which will come here. Let's see how we will arrive there. But if I have robbed the house with value 3, I cannot rob the house with value 9 because 9 is adjacent to 3. But I can rob the house with value 7. So basically, in case we have picked the value 3, this sub-array is still valid for me. By valid, I mean I cannot consider this element which is next adjacent, but I can consider rest of the elements which are not adjacent to it. And I already know the answer for 2 comma 7, which I have calculated here. So here, what will happen is if I pick 3, I will get the value 3 because I am robbing the house with value 3. Then I will get whatever is the value for 2 comma 7, which I have already calculated, which is 7. So this is the case when I'm choosing to rob the house with value 3. But let's say, since I don't know which option is optimal for me, I don't know which will give me the overall maximum result by robbing the house with value 3 or not robbing it. So this is the case when we consider that I am robbing that house. So let's say now I am not robbing this house. I am not considering 3. Then can I rob the house with value 9? Yes, absolutely, because 3 is not considered by me. So in this case, what will be my total amount of money which I will get? Since I did not rob 3, it will give me 0. Or you can simply say you're not getting anything. But then this sub array is what you can consider for your overall result. And I have already calculated this in one step, like in the previous step, which is 11. So to write this, if I don't rob the house with value 3, I will simply get 11. So this will be 7 plus 3, 10. This is the case when I considered 3, and this is the case when I did not consider 3. So now what should be the result? If I simply ask you, you will simply say I have two choices, whichever is the maximum, that should be my overall result, which will be 11 in this case. Now let's take the entire array and things will become perfectly clear. Okay, so now we are considering the entire array. Now let's repeat our thought process which we did in previous step. I am at value number 1. I have two choices. I can either rob this house or I can not rob this house. So let's first try to write what will happen if I rob this house. I will get the value 1. Then I cannot pick 3 because 3 is adjacent to 1. So it will be ignored. But 2, 7 and 9 is the array which I can still consider because that part is not adjacent to 1. And I already know what is the output for 2, 7, 9 because I have previously calculated it, which is 11. So if I am robbing the current house, which is the last house, which is 1, I get 1 plus the value for 2, 7, 9, which is 11. So this is my case number 1. But let's say the other choice that I have is that I will not rob this house. If I don't rob this house, I will what will be my total value? It will be whatever is the value for 2, 7, 9 and 3, which I have also previously calculated, which is 11. So the other choice comes out to be 11. And out of both of these two choices, maximum value will be 12. So my overall result will become 12. And we can compare it with the expected output, which is also 12. So using this dry run, we can start to visualize how we are trying to build the solution. Basically, if I have any given array, by using the previous two steps, I can arrive at my solution. So let's try to see how our DP table will look like and how we are going to populate that. Then it will become more clear. Okay, so our DP table will just be a one-dimensional array, and its size will be same as the size of the total number of houses. And here dp of I will simply represent max money for first I houses. And now using this dry run that we just did, we can try to see how we will arrive at dp of I. So I basically have two choices. First choice was I consider the last element, which will be present in nums of I. If I choose to rob this house, I will get the value nums of I or numbers of I, whichever is the name of the variable, that is not important. And after that, I cannot consider the previous element, which is I minus 1, but I can consider the element which is two spaces behind. And its result will be present in dp of I minus 2. But this is not over, because this is not the only possibility for me. The other possibility is that I don't rob the ith house. If I don't rob the ith house, what will be my what is the amount of money that I can get? It will be zero, because I have not robbed the current house. It's not giving me anything, but I can consider the previous cell. And ultimately I just need to take max of both these things. So if I try to write it down by simplifying it, it will simply become, so our dp table will simply be updated in this way. dp of I will be max of numbers of I plus dp of I minus 2, comma dp of I minus 1. That's it. And in the end, our solution will be contained in the last element, which can be arrived at by dp of length minus 1. So that's pretty much it. But there will be a couple of base cases, because since we are doing a look back here for a value of 2 and here for a value of 1, we will just simply need to ensure that whichever I we are considering, it should at least be greater than equal to 1 for this particular case, and it should be greater than or equal to 2 for this particular case. So we will handle that in the code. But overall, this is how our dp table will be updated by using a look back of 1 and 2 and using the current value. We just have two choices: either we can rob the current house or we can not rob the current house. We will consider them both and then take a maximum of whichever is giving me the higher value, and that will be my uh, that will be the maximum money possible for the ith cell. And in the end, we will simply return what is present in the last element of that array. So that's it. So now we will jump to the code, and the code will be very easy to understand if we understood how the table is getting populated. So this is the function that we have to complete. Let's start with declaring the dp array. It will simply be a one-dimensional array of size same as the length of houses, and in the end, the last element will contain our final result. And inside this loop, we will be filling this table. So that's it. So basically, we just need to consider the two cases that we had discussed, which is first, let's call it as, I'll call it as taken. Taken means that I am considering the ith house. So if I consider the ith house, what is my value? It is numbers of I plus do a look back of 2 and then add those two things. So initially I will get numbers of I plus dp of I minus 2. But since we are doing a look back of 2 here, we need to ensure that we are not running into negative indices. So we will just simply put a condition here. We'll simply put a conditional check that I should at least be greater than or equal to 2. If that is the case, I can do a look back of 2. Otherwise, this value will be 0. Now, this is my case number 1 when I have considered and when I am robbing house number I. Now let's see what will happen if I am not robbing the house number I. If I am not robbing, I will get a value of 0 first of all from the current house. Then I will do a look back of 1. And that's it. And again, similarly like the first case, we are doing a look back of 1. So we will put a condition that I should at least be greater than or equal to 1. Then only we can do this look back. If that is not true, I will only get value 0. And we can omit this 0. It is not necessary to write, just for explanation purpose. And in the end, now I have considered both the cases. We just need to take the maximum of both these things. So let's simply write math.max of taken comma not taken. So this is very short code, and let's try to dry run this and see if it works. Okay, so the basic cases are getting accepted. Case one was 1, 2, 3, and 1. The out our we are returning 4 and expected is also 4. And for 2, 7, 9, 3, and 1, our output is 12 and expected is also 12. 12. So let's just hope that this works for all other cases also. I'll try to submit it now. Cool. So now all the cases are getting accepted. So our logic is fine. If you still have any doubts or confusions, please use the comment section and we will see you in the next video.